This is a burn test on a traditional Australian or even North American construction. We've got some softwood, cedar, Baltic pine and radiata pine. We've got some skill errors here which are going to contribute to this burn. That is, the edges have not been rounded. We've got exposed end grain. We've even got some gaps in between the weatherboards and the weather stops. We've got recycled materials used here, but nothing's been filled in. And we've also got on top some maintenance issues, some leaf litter building up in the gutter. These materials here obviously aren't going to burn, but the combination of the gutter and the roof is going to direct the fire right to where we don't want it, which is inside the roof space. So we're going to light this up and see how it goes. So this is our second burn test. This cube here is built in the same manner as our house, the same techniques and same materials. On top we've got a ply cladding, which is known as shadow clad. It's 12mm thick and it's got 3 coats of intumescent paint on it. Intumescent paint is going to puff up when it receives heat, and we'll see that, and we'll get to see the aftermath of that in a minute. Intumescent cork around the gaps and along the grooves too, which is great for weatherproofing. The steel on top is 3mm steel, and all the gaps have been corked with fireproof silicone. Down here we have natural timber. There's 2 timbers, a silvertop ash and red ironbark. Red ironbark in particular is extremely dense and takes a lot of ignition. So too does the silvertop ash. It will take a lot of heat and a lot of flame to get that ignited. The edges have been rounded, the board is smooth, it's been coated in varnish, which will keep it fresh, making it harder to ignite even in the future. The edges, once again, all the gaps have been filled with cork and silicone. Over here we have corrugated iron. It's 0.5mm thick, it's standard Colorbond. All the gaps have been filled with silicone, and it's screwed in a standard manner for a house. On the bottom we've just got a Colorbond flashing. For the purposes of this test I'm going to steer clear of the bottom because it's not sealed. Underneath it, the inside of this cube is filled with insulation as it would be on a house. Same size stud, 70mm. And within it here we've got this box replicating the inside of a house. So inside that I'm going to place this glass of water and we're going to see how hot that water gets. So the test we're going to do is a flame zone test. If we're using an LPG cylinder, it is extremely hot. We're going to give it a lot of flame. It is exaggerated, as too was the former test with the weatherboard house. So after 3.5 minutes of intense flame, we can take a look to see what happened here. On top we had the intumescent paint. Everything here is still intact. The timber did not even touch it, didn't even get close to it. This is our timber wall here. You can see it's toasted the back, but no ignition whatsoever. And around here we have the Colorbond side here. You can see the way that that intumescent cork is puffed up at the bottom to protect the material underneath. This is actually fared probably the worst out of all the sides. We did have some flame ignition along the side here. That was the cork and the silicon burning, but the fire went out very quickly. I'll call that test a success for now, until we open this up and have a look underneath. There's our cup of water, still intact, and would you believe it, it's still properly cold. So underneath here, we didn't seal around the bottom, so we got a bit of flame coming in here, and it's melted a bit of the tape. Still no ignition thanks to the earth wool, which is fire resistant. Also had, thanks to the air gap, sisolation, which is fire resistant, didn't ignite either. Small amount of burning due to the flame coming underneath, but our box completely still intact. Still cool to touch on the inside.